Hello everyone, in this video I shall tell you how to perform the optimality test. So now this is the optimality test in case of transportation problem. Now but before I start, don't forget to like, share and subscribe for more such videos. So in case of transportation problem, when we test the optimality, we have two methods of testing the optimality. One is known as the stepping stone method, the other is known as the modified distribution method, called the Modi method. Modified distribution method, also called as the Modi method. So in this video I shall be discussing with you how to perform a stepping stone method to test the optimality. Optimality means, optimality का मतलब क्या होता है? आफ्टर फाइंडिंग आउट द फीजिबिलिटी, फीजिबिलिटी में मैंने आपको बताया था कि फीजिबिलिटी में आप चेक करते हो कि आपकी डिमांड सप्लाई सेटिस्फाई होती है कि नहीं होती है, डिमांड एंड सप्लाई आर सेटिस्फाइड और नॉट. And in case of optimality, you try to minimize the cost. So the objective is to minimize the cost. So for example, I've taken a matrix and I've made the allocations also. Using Vogel's approximation method, because Vogel's gives you the nearest solution to optimality, so you should always use Vogel's while making a optimality test before using optimality. So this is the allocation. So I'll check my rim requirement. Rim requirement is always the number of rows. Here we have 3 rows, with the formula is m plus n minus 1. So it is the number of rows, it is the number of columns minus 1. So number of rows are 3, number of columns are 3, and minus 1 it is 5. So 1, 2, 3, 4, and I also have the 5th allocation over here. So 5 allocations are there, so I fulfill the rim requirement. Rim requirement is m plus n minus 1 should be equal to the number of stone squares. Now what are stone squares? Stone squares are the ones where the allocation is made. So stone squares are the squares with an allocation, and watered squares are squares without allocation. So since we are fulfilling the rim requirement is fulfilled, so there is no degeneracy. That means that the solution can be performed. We do not fall short of the rim requirement, so we can the solution is non-degenerate. So the problem is non-degenerate, so we can perform a solution. So this is how you check the rim requirement, whether there is degeneracy or not. And I'll be talking about the stepping stone method in my next video. So stay tuned and for more videos and watch more videos. Thanks for now.